Hi, I'm Mark and I'm an Ableton Certified Trainer. In this two-part video series we're taking a look at MIDI Polyphonic Expression, or MPE, which is now available in Ableton Live 11. In the first video we took a closer look at how MPE works, used push to record polyphonic pad pressure, and explored the new Expression tab to apply sound design techniques to Wavetable. In this second video we will explore some dedicated MPE controllers and how they can be configured with MPE enabled instruments in Live 11. We will also take a look at MPE in Max for Live. MPE allows for 5 dimensions of polyphonic expression to be played and recorded for each note via an MPE controller. This means that for each note being played, as well as velocity and release velocity, we can also apply per note pitch bend, where we glide from left to right when holding a note. We can use slide, where we slide up and down on a note, and pressure, where we apply more pressure and press into an already held note. What these different forms of expression control depends on the instrument being used and how the modulation is being configured. If you plan on using an MPE controller, you'll need to enable MPE for it in the MIDI preferences. I'm currently using the ROLI Seaboard Block as my MPE controller, so I'll click the MPE option to enable it. This essentially tells Live to receive polyphonic control data from the controller. Let's take a look at some of Live 11's MPE instruments in action. You'll need to use an MPE enabled instrument to work with an MPE controller, and a great way to get started and to get a feel for working with MPE instruments is to try some of the new presets. These can be found in the Sounds category under MPE Sounds. Let's try this example out. If I slide up and down, we can hear quite significant changes in the sound, morphing between this low, subtle, filtered sound through to a brighter pad sound. Applying more pressure to the note opens up more frequencies also, adjusting the tonality further. And gliding from left to right applies pitch bend. The exciting part of this is that all of this works on a per note basis. So if I hold 2 notes down together, I can apply more pressure or slide to one note to make it brighter, leaving the other note as it is. Let's record something and apply some polyphonic expression at the same time. As you can hear, the pressure, slide and pitch bend have all been recorded and played back along with each note. We can now inspect this polyphonic control data inside the clip via the new Expression tab. In the same way you might quantize the notes you've played and tweak their velocities, we can also edit and tidy up the MPE data that's been recorded for each note. Take a look at the first video in this series to see a more detailed overview of this area. I'm just going to tidy up some of the MPE data by clicking and dragging to remove breakpoints. I can apply curves if needed to smooth out the shape of modulation. And I'll add some additional pitch bend to one of the notes. Let's create our own instrument setting with custom MPE routings to control some parameters. For this example, I'm using the Sensel Morph. This is a great MPE controller that gives you the option to change the overlay to suit your taste and style of working. For this example, we'll use Wavetable. It's good practice to have your controller set up and ready so that you can test out your MPE controls as you work. Here we navigate to the modulation matrix on Wavetable. Notice there's a new section for MPE which allows us to map specific expression coming in from the controller to different sound modifying components of the instrument. Let's leave the pitch bend at 0 for now and apply the up-down slide movements to the wavetable position for oscillator 1. Now, by pressing a note and sliding up and down, the wavetable position follows. The important thing to note here is that any MPE routing applied works on a per note basis, so if I now play 2 notes and apply alternating slide patterns, one note's wavetable position will move up as the other one comes down. Let's turn on oscillator 2 and map slide to its wavetable position. This time I'm going to invert the routing by dragging left on the routing matrix. This will mean that sliding up on a note will move the wavetable position down for oscillator 2, but oscillator 1 still moves up with any upward slide movements. Let's now focus on MPE pressure. I want to create a tremolo effect that gets more intense when more pressure is applied to a note. Let's first of all map LFO1 to the amp. The LFO waveform will force the amplifier to move up and down to simulate a tremolo effect. Let's now apply MPE pressure to the LFO amount and set the amount to full. This will increase the amount of LFO, or tremolo, applied when we apply more pressure to a note. Let's also apply pressure to the LFO rate. This will speed up the rate of the LFO when more pressure is applied. Let's now apply pressure and slide to a few more parameters to finish things off. As you can see, it's possible to apply MPE modulation to multiple parameters with varying levels of depth and polarity. Designing your own sounds to be used with an MPE controller in this way is quick and intuitive. MPE has also been extended to Max for Live. Let's take a look at some of the Max for Live devices that come bundled with Live 11. MPE Control is an MPE utility device and can be found in the MIDI effects category. Although many MPE controllers will come with their own software to configure their settings, the MPE Control Max for Live device offers a quick way to essentially fine-tune, shape and transform incoming MPE modulation, and the settings will save with your Ableton Live project. We can focus on a particular category of data to work on, such as pitch bend, pressure and slide, and here it is possible to change the response for each dimension. A really useful feature of the MPE Control device is the smoothing. This allows us to smooth out modulation data. This could be set to a large value, for example, to create longer transition times between movements on your controller. Or just subtle smoothing to avoid any jittery modulation jumps. The device can also convert MPE data to non-MPE MIDI. This means that the polyphonic MPE data coming from a controller can be used to control a non-MPE instrument. So we could use the sliding up and down on the Sensel Morph in the same way we would use a modulation wheel on a regular MIDI keyboard. When using this feature, the device prioritizes the last note played as the one whose expression will be used to control the whole instrument. The MPE Control device also offers useful visual feedback on the notes and expression being generated. The Expression Control Max for Live device is now MPE compatible, and as well as regular MIDI, can use incoming MPE Control data as mappable modulation sources to live parameters. Here we have slide being mapped to the delay send of our instrument track. Although the incoming data to the device is polyphonic, this control is only applied monophonically, and again it is the last held note whose slide data is used to control the map parameter. If you're a Max for Live programmer, you can use some of the new MPE based objects to build MPE instruments and effects that work inside Ableton Live 11. There are already some third-party instruments and MIDI effects available that make use of these new MPE features. Ableton Live 11 harnesses the creative potential of MPE, whether using a dedicated MPE controller or not. Working with MPE-enabled instruments and effects make the sound design process fun and intuitive. And with the addition of MPE compatibility in Max for Live, there are already unique interpretations of how expressive control can be integrated into the music making process.